Let's take a look at the next question. Problem number 38 asks us to simplify. We have the cube root of negative 27 times a to the 11th times b to the 10th. We can work on the number part first. First of all, the cube root of negative 27 is negative 3, because when you multiply negative 3 by itself 3 times, you get negative 27. The next part we can work on is the variable terms. Let's look at the cube root of a to the 11th part. A slick and easy way to do this is you can actually divide the index into the exponent. We have a cube root, so that's a root of index 3. 3 can go into 11 3 times. 3 times 3 is 9. And we have a remainder of 2. The number of times that the index can divide into the exponent evenly tells you how many power of that variable can come to the outside. So I can bring 3 powers of a to the outside. And then because I have a remainder of 2 when we do our division, that tells us that 2 powers of a will remain on the inside. Similarly, let's handle the b part. I can divide the index into the exponent. 3 will go into 10 3 times with a remainder of 1. So 3 powers of b can come to the outside, and 1 power of b, or b to the first, will remain on the inside. So that's our final answer. This reduces to negative 3a cubed b cubed times the cube root of a squared b. In problem 39, we want to simplify the square root of 8x squared y. Let's first work on the number term. If I want to simplify the square root of 8, this is divisible by the perfect square 4. 4 goes into 8 twice. So I can rewrite the square root of 8 as the square root of 4 times the square root of 2. And then the square root of 4 is just going to be 2. So that's 2 square root of 2. So I'm going to have a 2 coming on the outside. I'm going to have a square root of 2 left on the inside. We can still do our index trick to kind of simplify the variable parts. For the x term, if it's a square root, it's understood to be index 2. 2 goes into the exponent of x once. 2 goes into 2 once. So I have 1 power of x coming in, and because it goes in evenly, there's no powers of x remaining on the inside. For the y variable, it has an exponent of 1, which is smaller than the index, which tells us that we won't be allowed to bring any powers of y to the outside. So our final answer is 2x times the square root of 2y. And it looks like there's a little bit of an extra space there, but it should look like this. 2x times the square root of 2y. Let's take a look at number 40. Now we're getting into our rational exponents. With number 40, one of the things you might do in the beginning is notice that because we have a negative exponent, we can make that exponent positive by doing the reciprocal of the fraction on the inside. So let's reciprocate first, and then that'll make our exponent positive. Whenever you're raising a fraction to a power, that's the same thing as raising both the numerator and the denominator to that power. So this is the same thing as 125 x to the 6th raised to the 2/3 power over 27 raised to the 2/3. The 2/3 power is a combination of a radical and an exponent. It's going to be the cube root of 125 over x to the 6th squared divided by the cube root of 27 squared. The cube root of 125 x to the 6th should give you 5x to the 2nd, which will be squared. The cube root of 27 is 3, which is also going to be squared. 5x squared squared will give us 25x to the 4th, all over 3 squared, which is 9. So that's our final answer, 25x to the 4th over 9. In 41, we want to simplify this as well. There's a property of square roots that says if you have a square root of a numerator divided by a square root of the denominator, so that's the quotient of two radicals, that's the same thing as the radical of the quotient. So this is the square root of 176 x to the 9th divided by 11x. If we simplify what's on the inside, 11 goes into 176 16 times. X to the 9th divided by x is x to the 8th. And then the square root of 16x to the 8th is going to be 4x to the 4th. Let's take a look at number 42. We want to subtract these. These are not like radicals in the beginning. However, each of them could be simplified to begin. 18 is divisible by the perfect square 9. 9 goes into 18 twice. So the square root of 18 can be written as the square root of 9 times the square root of 2. 8 is divisible by the perfect square 4. 4 goes in twice, so we can write the square root of 8 as the square root of 4 times the square root of 2. And the square root of 200 is divisible by the perfect square 100, which goes in twice. We can now evaluate the perfect squares that we know. The square root of 9 is 3, so that comes to the outside. The square root of 4 is 2, and the square root of 100 is 10. Once you take those square roots, those now move to the outside. You can multiply them with the pre-existing numbers on the outside. Negative 5 times 3 is going to be negative 15 square root of 2. This will become a minus 4 square root of 2. And this one here will become a minus 30 square root of 2. At this point, they're all like terms, so we can combine them. Negative 15 square root of 2 minus 4 square root of 2 minus 30 square root of 2 should give us a total of negative 49 square root of 2. Let's take a look at 43. This is a multiplication. We have a binomial times a binomial, so we have to FOIL. 5 times 6 is 30. 5 times a negative square root of x is negative 5 square root of x. Negative square root of x times 6 is negative 6 square root of x. And a negative square root of x times a negative square root of x will give us a positive square root of x squared. So we multiplied everything out. We have 30. The middle two terms are like terms, so those can combine. Those will give us a negative 11 square root of x. And then lastly, the square root of x squared simplifies to just x. There's no like terms, so we leave our answer just as it is. 30 minus 11 square roots of x plus x. In question 45, they want us to rationalize the denominator. To do this, we want to multiply the numerator and denominator of our fraction by a value that will give us a perfect square in the denominator. The perfect square that 5 can divide into is 25, and 5 goes into 25 5 times. So what that tells us is we're going to multiply the top and bottom by the square root of 5. In the numerator, we get 8 square roots of 5. In the denominator, the square root of 5 times the square root of 5 would be the square root of 25, which would be just 5. It has now successfully been rationalized because we were able to remove the square root from the denominator.